Welcome to the derivative. So officially, the derivative of f of x at x equals c is given by the notation we are going to use is we will do an f apostrophe for derivative of x. This is equal to the limit as h goes to 0. Sorry, that should be f prime of c. I apologize for that. Well, f prime of c is equal to the limit as h goes to 0 of f of c plus h minus f of c all over h. So again, this notation on the side, this is the derivative of f of x at x equals c. The derivative of f of x at x equals c. And we sometimes say this as f prime of c. So if you hear me say f prime of c, that's just basically reciting how it's written. It's another way that we refer to the derivative of f at c. So just a note. F prime of c, the derivative of f of c, is the same as the instantaneous rate of change at x equals c. So for an example, let's go ahead and find the derivative of f of x equals x squared plus 2 at x equals 3. So we want f prime of 3, which we know is equal to the limit as h goes to 0 of f of something minus f of something. The first one will have f of something plus h. And then we're dividing by h. The thing that goes in all those blanks would be that 3, since we are looking for f prime of 3. So we will have a limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. So at this point, let's do some simplification off to the side. So we'll do f of 3 plus h in purple and f of 3 in blue. So our f of 3 plus h, we have 3 plus h, the whole thing squared, and then plus 2. Again, remember 3 plus h, the whole thing squared. We are looking at 3 plus h times 3 plus h. So we wind up with 9 plus 6h plus h squared, and then we add 2. If we rearrange this and combine like terms, we are simply looking at h squared plus 6h plus 11. Then the other thing that we needed was f of 3. So f of 3, we have 3 squared plus 2, better known as 11. So now we are going to go ahead and plug in those simplified versions into our original difference quotient. And we get prime of 3 is equal to h squared plus 6h plus 11 minus 11 all over h. Again, oh, sorry, I forgot my limit. This is equal to the limit as h goes to 0 of h squared plus 6h plus 11 minus 11 all over h. So here was our f of 3 plus h. And here was our f of 3. At this point, we simplify, and we are looking at the limit as h goes to 0 of h squared plus 6h over h. This goes to our 0 over 0, which is indeterminate. That could be 0, infinity, or anything in between. So we are going to go ahead and simplify. If we factor out an h, this is the limit as h goes to 0 of h times h plus 6 all over h. And we can cancel the h we factored out with the h in the denominator. And then go ahead and just plug in our h equaling 0 to get a final answer of 6. So we got that f prime of 3 is equal to 6, or the derivative of x squared plus 2 at x equals 3 is 6. And let's go ahead and do one more example. So let's consider the function g of x equals negative 2x squared minus 3x. And our job is to find the derivative at x equals negative 1. So what do we want? We want g prime of negative 1. And we know that this is the limit of the difference quotient. So we're taking the limit as h goes to 0. We will have a g of something plus h minus g of something all divided by h. And the thing that will go in our blanks will be that negative 1, since we are looking for g prime of negative 1. So we will have the limit as h goes to 0 of g of negative 1 plus h minus g of negative 1 all divided by h. Again, we'll go ahead and simplify it off to the side. So we will need g of negative 1 plus h. We will do that in purple. And g of negative 1 we will do in blue. So g of negative 1 plus h. We are looking at a negative 2 times negative 1 plus h quantity squared minus 3 times negative 1 plus h. Let's go ahead and multiply out that negative 1 plus h squared. We have negative 2 times 1 minus 2h plus h squared. And then we have minus 3 times negative 1 plus h. We can then multiply in those the negative 2 and the minus 3. We have negative 2 plus 4h minus 2h squared. Then we get a plus 3 minus 3h. And if we combine like terms and rearrange, this becomes negative 2h squared plus h plus 1. And then the other thing we needed was g of negative 1. The g of negative 1, we will have a negative 2 times in parentheses negative 1 squared minus 3 times negative 1. This becomes negative 2 plus 3, or simply 1. At this point, we know the two pieces that we needed to fill in into our difference quotient. And so we can go ahead and move forward. So we now have g prime of negative 1 is equal to the limit as h goes to 0 of negative 2h squared plus h plus 1 minus 1 all over h. Again, the negative 2h squared plus h plus 1 is from that g of negative 1 plus h. And the 1 we are subtracting off is from g of negative 1. If we simplify further, we now have the limit as h goes to 0 of negative 2h squared plus h all over h. This again goes to 0 over 0. So we need to simplify. And we wind up with the limit as h goes to 0. We can factor out an h. And then we have a negative 2h plus 1 left inside. We're dividing by h. And we can cancel the h we factored out. We can plug in our 0. And we wind up simply getting 1 as our final result. So g prime of negative 1 is equal to 1. So this is finding the derivative at a point. And what we are doing is we are simply taking the limit of the difference quotient